Suppose you are going by car to your village. The village is 100 kilometers away from your home. You need 2 hours to reach the village. Calculate the speed. As we have learned in the previous session, to calculate speed, we use the formula speed is equal to distance divided by time. The distance traveled is 100 kilometers. The time taken is 2 hours. So, 100 kilometers divided by 2 hours, the answer will be 50 kilometers per hour. The speed is equal to 50 kilometers per hour. But is the speed of the car kept constant during the whole journey? No. How do we know the speed at each moment of the journey? By using a speedometer. What is the difference between this calculated speed and the speed read by the speedometer? Together, we will find out the difference. A distance of 100 kilometers is covered during a period of time which is 2 hours. We have calculated the speed 50 km per hour. 100 km represents the total distance covered by the car from start point, home, till the end point, the village. 2 hours represents the total time taken from home to village. So, total distance is divided by the total time. A value is obtained. This value, 50 km per hour, represents the average speed of the car. Average speed is the total distance covered divided by the total time needed to cover this distance. The speed of the car is not kept constant all the way from home to village. Instead, it changes many times during the journey. It might move slower during a period of time. It might stop to fix a tire or because of traffic jam. It might move faster during other period of time. If you look at the speedometer, you will read different values of speed while the car is moving. Notice at time T1, the speedometer reads 30 km per hour. This means that at T1, the car is moving at speed 30 km per hour, which means at this particular moment, at this particular instant, the car is moving at a speed of 30 km per hour. The speedometer reads the speed at a particular instant. T1, 30 km per hour. At T2, the speed is 60 km per hour. T3, 90 km per hour. These values of speed shown by the speedometer are called instantaneous speed. Instantaneous speed is the speed at a specific instant. So, there are two kinds of speed. Average speed, which is the total distance covered divided by the total time taken to cover this distance. Instantaneous speed, which is the speed at a specific instant. Open your booklet, worksheet 4, part 1. Read the paragraph, page 8, solve numbers 1 and 2, then check your answer. Please correct the values of the speed of the graph as follows. Number 1. Calculate the average speed of the cyclist. It's given that the cyclist covered 500 meters in 50 seconds. To calculate the average speed, we have to divide total distance by total time. 500 meters is the total distance, 50 seconds is the total time, so 500 meters divided by 50 seconds, 10 meters per second is the value obtained. This value represents the average speed of the cyclist. Number 2, referring to the graph, indicate the instantaneous speed at the following instants. 10 seconds. To find the speed at time 10 seconds, we have to refer to the graph. X-axis represents the time, Y-axis represents the speed. We look for 10 seconds on the X-axis. The corresponding speed is 10 meters per second. So, at time 10 seconds, the instantaneous speed is equal to 10 meters per second. The same method for instantaneous speed at time 30 seconds, 10 meters per second. At 40 seconds, 10 meters per second. Now, let's compare the average speed of the cyclist to the speed at different instants. They are equal, 10 meters per second. In this case, the motion of the cyclist is said to be uniform motion. The motion is said to be uniform if the average speed is equal to the speed at different instants. Let's have a look again at the graph showing the speed of the cyclist during the race. During the whole race, the cyclist is moving at the same speed, 10 meters per second. So, the speed in this case is kept constant. Thus, in uniform motion, the speed of the moving object is constant. There are different types of motion. Uniform motion is one of these types discussed in this session. You will be introduced to the other types of motion in the coming session. Please pause the video, solve numbers 3 and 4, page 9 in the booklet, then check your answers. Number 3, show that the movement of the cyclist is uniform. The average speed, 10 meters per second, is equal to the speed at different instants, 10 meters per second. So, the motion of the cyclist is uniform. Number 4, deduce the average speed between instants 15 seconds and 25 seconds. Since the motion is uniform, then the different average speeds are equal. Thus, the average speed between 15 seconds and 25 seconds is also equal to 10 meters per second. Let's solve this application. The table below shows the distance traveled by a cyclist as function of time. Calculate the average speed of the cyclist. Average speed is total distance divided by total time. The total distance covered by the cyclist is 40 meters. The total time taken by the cyclist to cover 40 meters is 4 seconds. So, 40 meters divided by 4 seconds, 10 meters per second is the value obtained. Let's calculate the average speed between time 1, 1 second, and time 2, 2 seconds. By applying the formula, average speed is equal to total distance divided by total time. What is the total distance covered between 1 and 2 seconds? At time 1 second, the cyclist is at distance 10 meters. At time 2 seconds, he reached a distance of 20 meters. How do we know the distance covered from 10 to 20 meters? We subtract 20 meters minus 10, 10 meters. Then the distance covered is 10 meters between 1 and 2 seconds. From 1 second to 2 seconds. How long is the period? Also we subtract 2 minus 1, 1 second. So 10 meters is covered in 1 second. 10 meters divided by 1 second is equal to 10 meter per second. The average speed of the cyclist between instants 1 second and 2 seconds is equal to 10 meter per second. We have 2 minutes to calculate the average speed between time 1, 2 seconds and time 2, 3 seconds. As a conclusion, to calculate the average speed between two instants, we use the formula d2 minus d1 over t2 minus t1. d2 minus d1 represents the total distance covered between the two chosen instants. t2 minus t1 represents the duration between the two chosen instants. The cyclist at time 1 second is at distance 10 meters. At time 2 seconds, he reached a distance of 20 meters. This means that he covered 10 meters during 1 second. From 10 to 20, 10 meters are covered. He continues moving to reach a distance of 30 meters. From 20 to 30 meters, also 10 meters are covered. He continues moving to reach 40 meters. From 30 to 40 meters, 10 meters are also covered. This means that every 1 second, the cyclist covers 10 meters. A cyclist is covering constant distance during equal interval of time. Constant distance 10 meters, equal interval of time 1 second. The motion of the cyclist is said to be uniform. So, when a constant distance is covered during a specific interval of time, the motion is said to be uniform.